prove that any sum of even integers is even. Now, keep in mind, we're allowed to assume that the sum of any two even integers is even. But this is not exactly what we're trying to show. We're trying to show that any sum of even integers is even. So we want to show that also the sum of any three even integers is even, and also the sum of any four even integers is even, and so on. We want to prove all of these statements so that we can prove that any sum of even integers is even. We're going to do this with mathematical induction. Now we're going to let P of n be the statement that any sum of n even integers is even. Now we're going to prove that P of n is true for all n greater than or equal to 2. It doesn't really make sense for n to equal 1, although some would say P of 1 is trivial. I think this is going to be more interesting if we start with n equals 2. Now P of 2 is just the statement that the sum of any two even integers is even. So we're already done because we get to assume that this is true. This is something that we've proven in previous videos. Now we're going to start the inductive step the same way that we always do, by saying let k be an arbitrary fixed integer with k greater than or equal to 2, and assume P of k is true. So we're assuming that the sum of any k even integers is even. We want to show that the sum of any k plus 1 integers is even. Okay, so consider k plus 1 even integers. We want to show that the sum of these even integers is even. That's the goal. That's P of k plus 1. So to do that, we're going to take these k plus 1 even integers and split them up into two groups. So I'm going to call these even integers r sub 1, r sub 2, and so on, all the way up to r sub k plus 1. Now, I wrote the second to last even integer here because what I'm going to do is I'm going to split these even integers into two groups. One group is going to be a group of k even integers, and then we'll have this other even integer here. Now, by the inductive hypothesis, the sum of these k even integers is even. That's because any group of k even integers is even. And so if we want to add all of these numbers together, r sub 1 through r sub k plus 1, we have to take an even number here, which again, by the inductive hypothesis, the sum of the first k even integers is even. And then we have to add that even number with another even number. And we're allowed to assume that an even number plus an even number is even, which means that the sum of all of these even numbers is still even. And therefore, P of k plus 1 is true. And so by mathematical induction, P of n is true for all integers n greater than or equal to 2. Thanks, everyone, and I'll see you in the next video.